Now we talk about the idea of displacement. Let us say that you have this positive x direction here given, and this is the coordinate system. And let us say that there is a particle that was at x is equal to 1 at t equals 0. Let's call that A. And from there it moved to this point B, which is x is equal to 4 at t equals 2. So it has moved from this point to this point. We say displacement is actually a change in place. Look at the word place here. It is the displacement is basically change in place or position. Its position has changed from 1 to 4. This is the change in position. So displacement, we usually use the letter S. We don't use D. The D is used for differentiation. So displacement S is the change in this position. So we say delta, the letter delta is actually used for change. Instead of writing change, change, we just use this letter delta, delta position, right? And position is x, so therefore it is a change in x. Delta x means you read it as change in x. Now what is the change in x if it moves from A to B is basically what we need to find. So suppose I say S A to B, the displacement from A to B is actually change in position, which means I have to talk about the final position minus initial position. It's always final position minus initial position. Change is always final minus initial. So it is 4 minus 1, 3 meters. So my displacement SAB is 3 meters. On the other hand, suppose I moved from A to C. That means my displacement is SAC. I have moved from A to C. My final position is minus 3 minus my initial position was 1. My displacement is minus 4 meters. So I have gone from here to there. Well, you can say, well, no, actually you went from here to there and then you went from here to there. That doesn't matter. What matters is my position has changed from this point to this point, which means my final is minus 3, my initial is 1. Displacement only talks about a change in place or position. It doesn't care how you actually made the transition. Did you go jump like this? Did you go forward and then go back? Doesn't matter. And note that this displacement is negative and this displacement is positive. So displacement can be both positive or negative. A positive displacement means you moved in the positive x direction. And if you had a negative displacement, like in this case, you moved in the negative x direction. It doesn't matter what your initial or final x is. This is the way you have moved. You could have moved from minus 2 to minus 3. You could have moved from minus 2 to plus 1. If you moved from minus 2 to plus 1, your displacement is 1 because it is final is minus 1 minus minus 2. That will give you a plus 1. And if I went this way, then my displacement is minus. So how you move matters. You move in the positive x direction, then you have displacement is plus. And if you move in the negative x direction, your displacement is minus. So there is a related idea called distance, which you are more familiar with. So for example, if I went from A to B to C, let us say I went from A to B and then I went to C, and let's say I didn't change or do any turning anywhere, you use L to talk about distance. So we say L, my distance, is actually A to B, which was 1, 2, 3, plus B to C, which is 1, 2, 3, 4, 5, 6, 7. So my total distance traveled is 10 meters. This was LA to B to C. So it is LA to C actually. But if I talk about displacement from A to C, displacement is just a change in position. So it is minus 4. 2 points are important. One, displacement comes with a sign. Second, this number is different from this number. Why is that different? Because if I move from here to there, then the change in position only depends on this point and this point. It doesn't really matter what you did. That was the change in position. But if I look at displacement, well, you went forward, you could have gone back, and then you went forward again. I'm just separating this line out just to show you that you went back. You're all on the same line, right? So that means I have to talk about L1, and I have to talk about L2. Let's say that was L2, and then I have to talk about L3. And clearly L1 plus L2 plus L3 is going to be much more than just this simple length. So clearly path length or distance is a different concept from displacement. Displacement is a change in position. Distance is the path length covered. So this requires you to know exactly how you move. Whereas displacement just requires you to know what is your final position and what's your initial position.